And so now we're going to shift gears a little bit and move from the work that we're doing in assistance to the work that we're doing with agents and agentic AI. So first, let's start with a simple question. What is an agent? So this is a bit of an oversimplification, but I think it's relevant and helpful for us to use as an example. So agents are connected to large language models, allowing it to understand natural language. You then tell it what it's supposed to do, and we call these prompts or instructions. So there is an input, there is some processing that happens, and then there is an output. Now you can interact with these agents, and we actually create agents. They back all of our assistants. So you can interact with these agents like a chatbot, or these agents can run autonomously as well. So for example, I could say, I'd like to go to New Delhi. I'll be gone there for about 2 weeks. I want to visit all of the top restaurants in the area. Please generate me an itinerary. And what comes back to us is an itinerary. And many of us have used this prompt or a similar prompt in Chat GPT. But we also want to make this agent smarter, and we start by giving it tools. Tools are external capabilities that agents can call upon to accomplish certain tasks. And we also want our agents to have knowledge that they have learned from us in terms of the prompts that we give, but also knowledge that they get from LLMs and other experiences. And finally, agents have memory. They have memory of the conversation and the prompts that we've had with it for that particular session, but they also have memory of previous interactions, and they use that for future interactions as well. So agents and agentic systems have other properties worth noting as well. Agents can work in isolation. They don't need human interaction. Most often they work together with other agents and tools in a distributed fashion. And most agents and agentic systems are services-based, and they communicate with each other through protocols. MCP and A2A, or agent to agent, or model context protocol, and we'll get into that in a moment. Agents can also be orchestrated. So you're looking at here an example of specific knowledge-based agents that know about the ground, the topography, the wind in an area, as well as water in the area, and they feed this knowledge to a higher level agent that can provide information about wildfires. Agents can be created. They can be created in full code. They can also be created in a no-code environment, much like the apps and the custom experiences that you create today. And this agentic AI landscape is really emerging rapidly. There are many agentic AI platforms out there that you all are using today, or that many are using today to build agents. Some are experimenting with them, and some are putting these agents right into production. So there are agent platforms from Microsoft, from Google, from Salesforce. You're looking at a number of them here. And really, at a high level, our work in agentic AI falls into two different buckets. The first bucket on the left-hand side is geo-enabling third-party agents or clients with location platform or with location intelligence. And the other way in which we're working with agents is we want to bring agentic AI agents, we want to bring them the knowledge of location. So in one way, we are taking third-party clients and we're bringing location to it. In another way, we're taking GIS systems and we're bringing agents into that. So let's focus on agentic GIS applications. So here is the architecture diagram, actually, that we saw on the first day of the plenary. When we start to talk about agents, a new layer or tier gets created, and it's an agent tier. And these agents represent the core agents, in this case, that come with ArcGIS. And these agents use they use foundation models, and they have different agents that perform different tasks, like mapping, data exploration, perform data quality or assess data quality. They do navigation, they geocode, they perform analysis as well. Your applications can also leverage the agents that come with ArcGIS. We already do this in the assistance that we provide. And the number of the assistants that we just saw over the last hour are all brought to you and powered in the back end by a set of agents. But you can take these agents and you can bring them into your own agentic mapping applications, or in your own mapping applications, and make them agentic. So here we're looking at a modern agentic mapping application. We've seen a couple of examples of it already in the applications that leverage our assistant. It's got a modern interface. It's a very clean and simple interface, and the user is interacting with this application through natural language. Now, these applications can be built with absolutely no code. They can be built with full code, or they can be built with something we call vibe coding, which is to use natural language to tell an IDE what you intend to develop and write. And this is really incredible. And so to see a demonstration of this, I'd like to hand it over to Saranya.
Thanks, David. So AI components in ArcGIS JavaScript SDK enables developers to build agentic web mapping applications. So how can you get started? You can go through the documentation, look at the sample codes, even learn the best practices. So there is an alternative way to do it, which is vibe coding. But there are some prerequisites. First one, I need a web map. So here I have a web map of Mumbai showing the status of business licenses. You can go to settings under the web map section. There is an option to generate embeddings. So this is required to enable AI components in ArcGIS Maps SDK for JavaScript. Once this is done, you can go to the overview page and copy the item ID. Now I'll move to VS Code. You can use any code editor of your choice and any agent of your choice. So now I'll be using GPT 5.3 codex. So I'm just going to ask the agent to create a web mapping application using this web map ID, and please use the ArcGIS JavaScript API. My hope is that the agent should be able to reach the right documentation in ArcGIS JavaScript API page and build this application for us. So let us wait. Currently index.html is not there, so it is creating an index.html file, which is quite helpful. So let us give it some time to build it. So I can already see it is referring to the right web map ID, and I can see the index.html file. So let's go live. So it has loaded the right web map, but I can still see you thinking, where is the AI component, right? So let's go back and do an investigation. So it has used the JavaScript version 4.3, but the AI component is present in the version 5.0. So I'm going to nudge the assistant, telling there is a new AI component, add it in this app, and I'm also giving the URL to the document which I showed earlier. So let us see if it's able to reach out to the right documentation this time. Build the AI assistant chat component to our web application. So we saw in the documentation there are multiple out-of-box AI components. We have a help agent, navigation agent, and the data explorer agent. If the agent is able to reach out, it should be able to add some of these components and give us back. You can see it is already replacing the old 4.x map view with the new one. Okay, I can already see it is starting to refer to 5.0. Okay, all done. Career defining moment number 2. So now I can already see the assistant component loading. Security is important. All done. We have the map assistant on the right. So with two prompts, I was able to build an assistant for you. You can add additional prompts and change the look and feel to match your organization's template. So another way to get started with these AI components is through vibe coding. I hope you found this useful. Thank you. Over to you, David.
Saranya, I think I heard you say that was a career-defining moment, and I would agree with that, and you did an excellent job. Very good.
Thank you.
Excellent. We recently released new AI components in our JavaScript SDK. They're currently in beta, but they're available for you to use in the latest release, and they operate against ArcGIS Online. Enterprise is coming. These components are interesting because they leverage a multi-agent client-side architecture. So this means that you literally have an orchestrator that's running within your browser. And this orchestrator works with multiple agents. Some of the agents that come with the JavaScript SDK include navigation, data exploration, as well as various help agents and an assistant agent. But this orchestrator also works with a custom agent that you build upon a framework, an agentic framework that now is in the JavaScript Maps SDK. So to show us how to traditionally code a web application that is bringing agents to its core, I'll hand it back over to Saranya for another demonstration.
Thanks, David. So the AI components allows you to build agentic web mapping application. So this application allows end users to interact with the web map using natural language queries. So I'm going to show you the out-of-box components as well as how you can add your own agent to the application. So let's take a look at the application I've built. Here I have the citizen complaints. There are over 4,800 complaints in the city of Bengaluru. To the right, we have an assistant component which provides me a chat interface where I can interact with the web map using simple natural language. So here I can ask the agent to summarize the number of complaints based on the category. So what happens is there is an orchestrator which refers the large language model to understand the intent and pass it to the right agent. So in this case, it should go to the data exploration agent, which will summarize this, and it has already given us the result. So electrical complaint seems to be the highest. So something stands out to me, which is veterinary complaints. I'm curious to know if there are any incidents related to stray dogs. So I'm just going to ask that question. So here you can see I don't have any category called stray dog, but I'm assuming that the assistant should be able to go through all the fields that are present in the feature layer, and if it finds any incident related to stray dog, it should give us that. So it has already filtered the map based on that. There are about 157 complaints, and I can already see some pattern emerging. We have a cluster here, here, and here. So let me go in here, drop a pin, and ask it to show the 5-minute walking area from here. So this is where things get little interesting. So in addition to the out-of-box agents, I also have a custom location services agent running, which runs the service area analysis tool, and it has already given us the polygon. So how did I do this? Let's move to the code and understand it better. In index.html, I load my webmap ID and reference it in the ArcGIS map component. Inside the assistant component, I have the navigation agent, data exploration agent, and also a custom agent. And I have a location services graph.ts. So this is where I define the custom location service agent using LangGraph. So this is the description I wrote. And this particular code also has a registration component. And this particular graph has two nodes. The first node is an LLM node which understands the intent and selects the right tool, and a tool calling node which executes it. And I also have two tools here. One is the drive time, which did the service area analysis which we saw earlier. And I also have a tool to count the facilities. So to summarize, we saw how you can use out-of-box agents in ArcGIS JavaScript SDK, and also extend it and add your own custom agents. I'm looking forward to see all the agentic web mapping applications you will build using these. Thank you. Over to you, David.
Very good, Saranya. Excellent demonstration. So far, what Saranya has showed us is a fully code experience of building agentic mapping applications. But we also have no-code experiences. The new Data Explorer Instant App template, it's a new template within our family of instant app templates, has agentic capabilities built right into it. So it will allow you, so what you will do is, the same way that you use other instant app templates, you author a map, you pour that map into this template, and it immediately gives you an agentic experience to explore the map, to get at data summarization, to look at analysis, to see patterns in the map that you may not normally see all through natural language. So that was a look at how we're bringing agentic AI into ArcGIS. Now let's focus on the left side of this diagram, where we'll talk about how we're bringing GIS to third-party agentic ecosystems. And we do this by leveraging standards. And currently the de facto standard to do this is through Model Context Protocol, MCP. It's a protocol that makes external systems AI friendly. Now, I will say that a lot of the work that we're going to be doing in 2026 will be done around MCP. So 2026 really is the year for MCP. The agentic work that we just saw will come later in 2026, early 2027. Yes, it's available in beta now, but this MCP work is actually quite near to being released. Okay, so what is MCP? Well, we just mentioned that it's a standard for connecting AI applications to systems where data lives, and in our case, to GIS systems. So we've got an AI application. It's a third-party application. It uses an LLM, just like our AI applications do. And then we have a data source. And this data source, in our case, is GIS data. It's exposed as a service and also as an API. A REST API. All of our location services are exposed as REST APIs. We then use Model Context Protocol to expose these services as a set of tools. Now, there could be multiple tools for one service. It's not a one-to-one relationship. And once these tools are exposed, we then use MCP protocol from an MCP client to communicate with our location services. So In our roadmap for ArcGIS, we will be implementing MCP across many of the foundational products. So you can think of MCP as an interop standard. We'll expose our location services as a set of MCP tools, like several tools to geocode, to route, to get at static maps and demographics, and most importantly, an MCP server to get at your authoritative content, so to get at the feature services that you published. So MCP support will be available in ArcGIS Enterprise, in Location Platform, and also in ArcGIS Online. And importantly, it will adhere to the ArcGIS security model that you're already using. It won't use a different one or a new one. It'll have a deliberate design. It'll be engineered from the bottom up to adhere to the MCP protocol. We'll also look to expose certain tools in a very prioritized way. So, to help us visualize what an MCP server can do, I'd like to hand it over to Ewan and Saranya, who's going to show us MCP servers working with our location services, but also MCP server working with the portal in ArcGIS. So Ewan and Saranya, I will hand it over to you.
Okay, thank you, David. So I've got a very simple application here that I'm going to use to try and really get over what MCP really means and how an LLM can make use of it. So I've got a very simple chat application, and at the moment it's configured only to use the LLM, not to use any MCP. So I could ask it a question. It's expecting spatial related questions, so I could say, what is the elevation of the Eros Hotel in Delhi? And I'll send that off. Now it's being responded to by the LLM. Now at the moment, all the LLM has access to is the memory and the model that it's been trained on. And so it's found the fact that the Eros Hotel is in fact in New Delhi, it's in Nehru Place, but it doesn't know much more information about its location other than its approximate location. Its approximate coordinates, it's probably showing me the middle of Delhi here. And so because it's giving me approximate coordinates, it's giving me an approximate height. Somewhere in the model, it's found that Delhi is about 700 feet above sea level, but it's not sure exactly, because all it's got is that model that it's been trained on, and it can't reach into any of the rich GIS content that's available through location services. So let me just turn on the MCP nature. So now what the LLM has access to, the LLM now has access to tools exposed through an MCP interface onto location platform. So let me just re-ask that same question, and let's see what difference it makes. It's telling us it's going to access location services via MCP. The LLM is doing the reasoning. It's figuring out it's got to get an address. It's got to then get some more information, and sure enough, it's got a much better answer because it's had access to ArcGIS through the dynamic tools that are available through the MCP. So again, the LLM has found the fact that the Eros Hotel is in Nehru Place, New Delhi, but now it's been able to geocode that location using a tool coming from ArcGIS, and with that geocode, it's being able to get a precise measurement of 822.5 feet above sea level, and it's confident in that result because it's coming from that dynamic tool. And it's even generated a static map of the location here. And that's all possible because the LLM is now paired up with an MCP server. And the MCP server that it's using is the one that's buddied up to ArcGIS location platform.
Great.
So
Thank you, Ewan.
what MCP means to an LLM. It adds dynamic content and reaching into more richer data sources that the original LLM training model didn't have access to.
Excellent. Thank you, Ewan. Ewan's a little shy, so let's give him a round of applause. I thought that was an excellent example of asking the same question twice, one without spatial knowledge, and the second time Ewan asked that question, the client had spatial knowledge through tools exposed through an MCP server, and that spatial knowledge was coming from ArcGIS. So, Saranya, I'll hand it back over to you to complete our MCP demonstration.
Thanks, David. So, agentic AI is emerging rapidly, and organizations are moving from proof of concepts to production agents. But these agents can only be as smart and reliable as the data that they have access to. ArcGIS can geo-enable these third-party agents with rich geospatial tools and access to your authoritative data in ArcGIS Enterprise. This is done through MCP tools exposed in ArcGIS Enterprise, which uses the Model Context Protocol standard. So to see it live, let us go to Microsoft Copilot Studio, where I have an agent that can answer questions related to pipeline. Currently, it is not connected to MCP or any GIS tools, so let us ask a geospatial question and see how it responds on its own. Currently, it will use the general search knowledge of the GPT 4.1 large language model, and it has given us a response. So let us check that. So it says that the coordinates correspond to New Delhi, India, but in case of workflows like pipeline pressure sensors, we need a much more precise answer, right? Rather than a vague statement saying it corresponds to New Delhi. And it was not able to find any information about the nearest pipeline service center. So this is where geo-enabling becomes very important. You can do that by turning on or enabling the MCP tools in ArcGIS Enterprise. Now, just to check if it is able to reach out to ArcGIS Enterprise, I am asking a simple question. List all the ArcGIS feature services in Delhi. You can see on the left, it has already triggered the Model Context Protocol for ArcGIS Enterprise. It is doing a portal item search, and it has already listed all the services it sees in Delhi. Now, let us ask the same question and see how the response changes. Keep an eye on the left. You should be able to see the list of tools it triggers. It has done a reverse geocoding, and it's querying the layer, and it also did the route solve. So my question was, a pipeline pressure sensor has triggered an alert at this coordinate. Identify the location, find the nearest pipeline service center, and route a technician. So it has identified the location as Kartavya Path President's Estate, and the nearest pipeline service center as Mayapuri Industrial Depot, and it has given me the routing steps, and all the source is from ArcGIS Enterprise. We also have several other tools that you can access through MCP. So let us take a look at some of these tools. You can do portal item search, you can do geocoding, reverse geocoding, route solving, layer inspection. And in addition to this, you can also publish your own geoprocessing tools and call them here. So that was a quick demonstration of about how you can geo-enable third-party agents so that they become location aware. These tools can seamlessly integrate ArcGIS with agents like Copilot. I hope you found this useful. Thank you. Over to you, David.
Excellent, Saranya. Thank you for that, and Ewan, thank you for that as well. So here's a quick look at the architecture with MCP, and it's actually quite simple. So on the right, you pick your agentic system. It could be Gemini, it could be AWS, it could be something from Microsoft, and you build your agents in these systems. And it's these systems that connect to ArcGIS over MCP, and they essentially access services like we just saw. But I think what's interesting here is that in this architecture, there is no AI in ArcGIS. We're using the interop protocol, MCP, to expose our services as a set of tools that other AI clients and agents can then tap into. So to summarize our work around agentic AI, we're using and developing agents to power all of the assistants that you saw today. We're allowing you to build agents both in a no-code and a fully code experience. And we're also exposing our location services as a set of tools using model context protocol. So there's a lot of exciting work going on around AI and agentic AI. Thank you, everyone.